Adventurous kids explore with education and learning what a wildlife is in the Everglades. I want to explore the Museum of Discovering Science. What plants do butterflies like? I want to know about Key West. Adventurous kids, learning and fun. Adventurous kids!
Today we are going to tell you
about relativity.
Relativity is a scientific theory that explains how things like motion, time, space, and gravity work. The theory of relativity is actually two theories that Albert Einstein came up with in the early 1900s. One is called special relativity, and the other is called general relativity.
Special relativity deals with the relationships between speed, time, and distance. To start with, special relativity says that light always travels at the same speed, the speed of light, which is 180,000 miles per second. It turns out that there is nothing faster than light. It was this constant speed of light that inspired Albert Einstein to come up with the theory of relativity. Theoretically, if you could travel faster than the speed of light, time would go in reverse. But also, Albert Einstein found that it's impossible to tell whether you're moving unless you can determine that you're moving relative to some other object. Because of that, time and distance can't be absolute. It can change. Another interesting result of special relativity is length contraction. Length contraction is when objects appear shorter the faster. They are moving in relation to the observer. This effect only occurs as objects reach very high speed. Special relativity also gave us probably the most famous equation of all time. E equals mc squared. In this formula, E is energy, m is mass, and c is the constant speed of light.
The other type of relativity is called general relativity. When Einstein wrote about this, he was trying to describe the force of gravity. The one big discovery of his was that gravity is equivalent to acceleration. So the force that you feel when you're lifted in an elevator feels the same as the force of gravity pushing you down. But more importantly, general relativity says that gravity can affect time and space. In Einstein's theory of general relativity, he proposes that time will run more slowly the stronger the gravity. This means that time will pass faster on top of a mountain than at a beach. You will actually age slower at the beach than the mountains. This is a very small difference. However, nothing you would notice. Another concept from general relativity is that rays of light will bend in a gravitational field. The sun actually bends light enough that we can see stars that are barely behind the sun. However, it takes a huge amount of gravity to bend light significantly. As big as Earth is, it hardly bends light at all.
One of the most interesting results of the theory of relativity is time dilation. Time dilation says that time will pass slower for someone traveling near the speed of light relative to someone standing still. As an example of time dilation, let's imagine you left on a space flight today. On that space flight, you flew around outer space near the speed of light for around 3 years according to your clock. However, the clock on Earth was moving much faster. In fact, more than 60 years have passed on Earth. You would only be a few years older. Everyone on Earth would be much older. The faster you're going relative to a certain frame of reference, slower the time goes for you. The effect has been demonstrated at slower speeds. Clocks on airplanes have been shown to tick a teeny bit slower than clocks on the ground.
For Albert Einstein, the universe's forces were best described by the English physicist Isaac Newton. Newton's explanations for things like gravity worked perfectly well with most of time. They fell short when trying to explain very large and very distant objects. So being the genius that Einstein was, Albert Einstein came up with a better explanation and that turned into his theories of relativity.
Many aspects of the theory of relativity have been confirmed by experiments run with particle accelerators. Particle accelerators can accelerate electrons and protons to nearly the speed of light.
Thank you for watching this episode
of Adventurous Kids. Stay blessed.
What did you learn today? Adventurous kids! Adventurous kids! What was the most interesting fact? Adventurous kids! Adventurous kids! Adventurous